Thankfully, at least many of you probably think this way, we're out of the fractions chapter now and we're into the decimal chapter. All right, so we're going to work on decimals and operations with decimals. Honestly, operations with decimals are not a huge thing because for the most part, I just allow you to do those operations on the calculator. I'll show you the basics in this video, but um, it's not going to be super important because most of the problems you get with decimals are going to be application problems that you can use a calculator for. So first thing to realize is that really decimal notation is just an alternative method of writing fractions that have denominators that are powers of 10. It's really just an expansion of our place value system. So if you remember our place value system, we had as you move further to the left, each place multiplied by 10, right? So like this number here on the left side of the decimal point would be 1,234. So if you recall, this 1 really meant 1,000, right? This 2 really meant 200. This 3 really meant 30. The 4 meant 4 because this was called the thousands place, which is really 10 to the third power, right? Because 10 times 10 times 10 is 1,000. This place here was called the hundreds place. That was 10 to the second power. This place was called the tens place, which was 10 to the first power. And this place was called the ones place. And we didn't talk about zero exponent, but really 10 to the 0 power actually means 1. So that's how these places worked, right? So that was really 1,000 plus 200 plus 30 plus 4. Now we're actually going to go to the right side of the decimal point also. So any number that's expressed in decimal notation consists of the integer part, right, which is what we just had here. That was the 1,234. Then you have a decimal point, and then you have a decimal part. So in this case, the decimal part is this 5678 here. All right, and each digit is going to have a value based on its place, right? So if you look, this 5 here doesn't really mean 5. It really actually means 5 tenths because this is what's called the tenths place, right? This 6 doesn't mean 6, it means 6 hundredths because that's what you would call the hundredths place. The 7, not surprisingly, means 7 thousandths because that's the thousandths place. And then of course the 8 is going to mean 8 ten thousandths because that's the 10 thousandths place, right? And the thing to notice is, because I think some people confuse this, there's no oneths place, right? Because the oneths place would be the same as the ones place, right? Because if you have a denominator of 1, it was really just the whole number, right? Remember we could write like a number like 6 as 6 over 1. So there is no oneths place, it's just the same as the ones place, all right? And again, the idea of decimal exponents, we don't do negative exponents, but the tenths place is really, and it shouldn't be surprising based on this pattern, right? 10 to the third, 10 to the second, 10 to the first, 10 to the 0. The tenths place is actually 10 to the negative 1 power. The hundredths is 10 to the negative 2 power. The thousandths is 10 to the negative 3 power, and the 10 thousandths is 10 to the negative 4 power. All right, so if you were going to read that number, the way you read numbers in decimal notation is you read the number to the left of the decimal as a whole number, right? So 1,234. When you read the decimal point, you say the word and then you read the number to the right of the decimal point like it was a whole number. So 5,678, but then you have to say what that last decimal place is, and that last decimal place is the 10 thousandths. Right? So that's how you would read that number, 1,234 and 5,678 ten thousandths. All right? So decimals are really just another way of writing fractions that have specific denominators, right? Namely denominators of 10, 100, 1,000, 10,000, so on and so forth. Okay? So that's the idea of decimals. And then rounding numbers in decimal notation is just like rounding integers, right? What you do is you look at the digit that's to the right of our rounding place, and if that number is 5 or greater, you add 1 to the rounding place digit, and you chop off the digits that follow. This is the one thing that's different with decimal rounding than with whole number rounding. You actually chop off the digits that are to the right of the decimal point after the rounding place, so we'll look at that shortly. So if the number to the right of the rounding place is 5 or greater, you add 1 to the rounding place digit, chop off the digits that follow, and if it's less than 5, or I guess you could say 4 or less here, right? Less than 5, we leave the rounding digit alone and chop off the digits that follow. So like the number that we just had, what was it? 1,234 and 5,678 ten thousandths. If you want to round this nearest, let's say, thousandth, right? You identify the thousandths place, right there. The thousandths place is this, but then remember what you do is you look to the right of that. So you look here, and it's 5 or greater, right? It's 8. So you add 1 to the rounding place digit, so that 7 is going to become an 8, and you chop off the digits that follow. So what you would do is this 7 would become an 8. I wouldn't write a 0 there, right? And I have to write everything before it, right? So it's 1,234 and 568 thousandths, right? That's how I would say that number, 1,234 and 568 thousandths. All right, so that's how you would round that to the nearest thousandth. And then if you were going to round it to the nearest tenth, let's say, what's the tenths place? The tenths place would be this 5. So remember what we do? We look to the right of that. So we look at the 6, and the 6 tells us, because the 6 is 5 or greater, to make that 5 a 6. So we're going to write 1,234, and now that 5 becomes a 6 tenths, and we chop off the digits that follow, right? The big mistake people make here is they write 0, 0, 0. No, you don't write those extra zeros. You chop off the digits that follow. So it's 1,234 and 6 tenths. All right. There is one tricky case that comes up sometimes when you're rounding with decimals. Like let's say, give a simple example. Let's say yes, 87.896, right? And I wanted to round this to the nearest hundredth. Well, the hundredths place is that 9, right? It's the tenths is the first one, the hundredth is the second one. So what we would do is we would look to the right of that. We'd look at the 6. 6 is 5 or greater, so it would tell us to make that 9 a 10 basically, right? Or a 0, let's say, and then you'd have to carry over the 1. So when you rounded this, this would actually become 87 point, the 89 basically would become a 90, but I need to write that 0 there to show that I rounded to the nearest hundredth, right? Now, if I had rounded to the nearest tenth, I would say 87.9 without the 0. But if you're rounding to the nearest hundredth, you need to keep that 0 there to show you rounded to the hundredth. Right? You need to keep that 0 to show that you rounded to the hundredth place. So just keep that in mind, right? If the digit that you're if the place that you're rounding to ends up being a 0, you still actually write it in there. So that's the one case that's a little bit tricky.